Hi. So today's journal is all of the sixth grade flashback journals that we didn't get to. So normally in the school year, we would have been doing sixth grade and seventh grade flashbacks all throughout the year. And I already have these questions written. The problem is with this school year that we did not get through anywhere near the number of journals that we normally would have gotten through. So that means that we've got some sixth grade flashbacks that we didn't get to. So today's journal, journal number 49, is all of those sixth grade journals. Now, that means that it's going to be kind of a long journal. So notice that it's not a Google form this time. This time it's a Google Slides. And that way you can work on a couple and then come back to it, work on a couple and then come back to it, and don't have to worry about the whole thing vanishing the way it does in Google Forms. In a Google Form, if you leave in the middle or whatever, it's lost. You've got to start all over again. So I did the Google Slides so that you have, flexibility. And then it'll remember your work. Please, though, when you're done with these, make sure you hit share, that orange share button that when you're not in the present mode, that orange share button up at the top, click that, and then share it with harris.kate@notawaysschools.org. So let's get started. The first question is, what are the phases of the moon? So you've got the new moon and the full moon. New moon is when it's completely dark and we can't see it at all. Full moon is when we can see the whole moon lit up. Then we have waxing, which means the moon is getting bigger. And we have waning, which means the moon is getting smaller. You've got crescent and gibbous. Crescent is when it looks like a fingernail. Gibbous is when it's most of the moon lit, but not all the way to full. Then you've got your first quarter and your third quarter, and that's when half of the circle is lit up. If you go to the next slide, there it is, and it shows you the position of the moon. Now, the moon isn't always dead exactly even with the Earth in relation to the sun. It can be up here or down here a little bit. However, it can also be directly lined up. And when that happens, when the sun, the sun's going to be here, and the Earth is between the sun and the moon. The sun's rays are hitting the moon fully, but if the moon is exactly lined up behind the Earth, the sun's rays have to bend around the Earth to light up the moon. So that's where we get those orange and red colored moons, because the light is having to bend around the Earth. And that's a lunar eclipse, when the Earth is between the sun and the moon. And we get those colors. So on the previous slide, you're just going to write these words: new moon, crescent, first quarter, waxing, gibbous, blah, blah, blah. Just copy all that into the text box on this first slide. All right, the next question is, where is the moon during a solar eclipse? And I guess when I started recording the other day, I typed in the answer and didn't erase it. So I'm going to have to go back and fix that. But a solar eclipse is when the moon gets between the Earth and the sun. And because of how far away the sun is, even though it's huge, it's so far away that the moon, with how close it is, and the sun, with how far away it is, are about the same size. So when the moon passes between the Earth and the sun, it blocks the sun's rays, and we get a solar eclipse. So of the positions of the moon, A is the one that is correct there. All right, what kind of clouds are thunderstorm clouds, and what are other types of clouds? Again, the next page has lots of answers that you can copy from. If I'm asking about thunderstorms, so nimbostratus are just a rain cloud, but cumulonimbus that have this big anvil-shaped top, those are the thunderstorm clouds. So you're going to, in the box, in the text box here, cumulonimbus are thunderstorm clouds. And then you're going to insert some names. From the next slide to name some other types of clouds. So cirrus, stratus, Fog is when it's on the ground, cumulus, etc. So fill that in for yourself. All right, so the next question, again, my silly tail apparently didn't delete this stuff and I don't have time to go back. So here we are. What are the two types of energy? They are potential and kinetic. And then how many forms of energy can you name? So the forms were those 6 forms. So chemical, electrical, nuclear, electromagnetic, mechanical, and thermal. The next question is about Virginia's watersheds. Want to know what the watersheds are in Virginia. We have done this one before, but I just wanted to review it once more. So when you hit next, when you're looking at it in presentation form, when you hit next, the answer is right there. The 3 major watersheds are the Gulf of Mexico, which drains this way, the North Carolina Sound, which drains down, and Chesapeake Bay, which drains into the Chesapeake Bay. So on your slide, you can just leave it there. There they are, Chesapeake Bay, Gulf of Mexico, and North Carolina Sound. All right, so the next question is, how is natural gas formed? And again, I gave you a slide that has some reminders from what we talked about when we talked about this, that we've got marine organisms from about 400 million years ago. When they died, their bodies got trapped in dirt and things that fell on top. And then over the years, pressure and time turned their bodies into good stuff. So you're going to put that in your own words here. Pause and go back and type it up. Something about ocean creatures from 400 million years ago. And when they die, their bodies give off gases and the gases are trapped. All right, moving on. What are the steps of the water cycle and how can it be used to create electricity? So the steps of the water cycle are what you know from elementary school: evaporation, condensation, and precipitation. So the water cycle is evaporation. Man, I can't type today. Condensation and precipitation. And it can be used to create electricity in a hydropower dam. So hydropower dams are used to generate, it corrected for me, electricity. Hydropower dams are used to generate electricity by collecting water behind a dam, and when it flows in response to gravity, it turns a turbine. All right, next one. What is an estuary and why is it important to keep it clean? An estuary is like a filter. So an estuary is an area of wetlands, marshy area where fresh and salt water meet. So like the Chesapeake Bay is I want to say it's the world's largest estuary. If it's not the world's largest, it's definitely the largest one in the United States. So the Chesapeake Bay is a huge estuary where the river water, the fresh water comes and meets the salt water from the ocean. Now, why is it so important to keep it clean? Estuaries act as filters, and dirty filters don't work. So if we've got a bunch of trash and junk and gunk in the estuary, then a bunch of stuff is going to also then make it out into the ocean or make it into our fresh water supply. So estuaries act as filters and dirty filters don't work. So we've got to keep it clean. Next one. What is the difference between a comet, an asteroid, a meteoroid, a meteor, and a meteorite? So all of those things are different. I've got this lovely little picture to talk about it. A comet is different from everything. A comet has ice in it. Comets also got sent on a path a long, long time ago, and they don't stop. They just go around and around. They get sucked into something's orbit, and they just go around and around and around. And they have a tail because you can see the bits that are coming off of them as they fly around. An asteroid is a rock, no ice, just a big rock in space, a huge rock in space. If the rock in space is smaller than a car, it's a meteoroid. Okay, so still both just rock, still both just rocks hanging out in space. An asteroid, huge, car-sized or bigger. Meteoroid is smaller, car-sized or smaller. Falling stars are not falling stars. Falling stars are meteors. What's a meteor? A meteor is a meteoroid that has started to fall through our atmosphere. So when we see that thing go across the sky and we see that blaze of light, that is the rock burning up in our atmosphere. Most of the time, they burn up and vanish before they can hit the earth. However, if they don't burn up as they go through our atmosphere and they do hit the earth, it's a meteorite. So that's when we get our meteorite, when it actually hits the earth. So asteroid, meteoroid, meteor, and meteorite are all the same thing. It's about size and location. Asteroid, huge in space. Meteoroid, smaller in space. Meteor, flying through our atmosphere, burning up. Meteorite, if it makes it and doesn't burn all the way up, it becomes a meteorite when it hits Earth. Most of these fall into the water and fall into the ocean because 75% of our Earth is ocean, so most of it falls into the water. Occasionally, though, they will hit Earth. A good place to find them is the desert. You can get a stick with a magnet on it and just swing the stick back and forth while you walk through the desert. And regular rocks aren't magnetic, but meteorites are. So it sticks to your magnet, you know you found yourself a meteorite. A large meteorite fell and hit in Russia a few years ago. I think it was 2008. And there's a lot of footage of it because it was 2008. So there's cameras everywhere. Lots of people had car cameras. There were street cameras. There were building cameras. So if you do a YouTube search for Russian meteorite, there's footage after footage after footage of watching this meteor fall from the sky and the boom when it hit. It almost caused lots of percussive damage, windows broken and things like that. So check it out if you're interested. I would prefer that if you would go back to this prior slide and put back what we just said. Comet has ice. Asteroid, big rock in space. Meteoroid, small rock in space. Meteor is a meteoroid that's in our atmosphere burning up, and a meteorite is a meteoroid that made it past meteor and managed to hit the Earth. What are Newton's laws and examples of each? So Newton's laws, there are 3 of them. Newton's 3 laws. This is taking a long time to minimize. All right, Newton's first law. I call it the school bus law. When we write it out, though, it's an object in motion tends to stay in motion. An object at rest tends to stay at rest unless acted upon by an unbalanced force. So if I have a kickball and I set it down on the ground in front of me, it's going to want to stay there unless it's acted upon by an unbalanced force. If it's on a hill, gravity is the unbalanced force that will pull it down. If it's on a flat surface, me kicking it is the unbalanced force that will make it go. Now, technically, in space, it would go and keep going because there's no air resistance, no gravity, no wind resistance. All right, but what about here on Earth? If I had a long hallway and I kicked that ball, eventually it would hit a wall. Okay, well, there's your unbalanced force that makes it stop. Well, what if there's no wall? What if it goes on forever? It still won't go on forever on Earth because gravity is pressing down on it and friction is pulling on it like this. So it's not going to go forever here on Earth because of those two unbalanced forces. So I use the school bus law because inertia is what we're talking about here. We're talking about the fact that when an object is moving, it wants to keep moving, or when an object stops, it wants to stay stopped. When you're on the bus and it takes off, what happens to you? Right? And what about when it stops? If you're going along and it stops suddenly? Right, because you're wanting to keep going forward, but it stops. So that's why the back seats of buses are so tall. All right. So example would be when you hit the brakes and something in your car keeps moving forward. All right. Second law. The bigger they are, the harder they fall. Force equals mass times acceleration. The bigger something is, and the faster it's moving, the more force it has. Think about it. If you were in a narrow hallway and couldn't escape, and there were two people running at you, and they were running the same speed, but one of them weighs 100 pounds, would you rather stand in front of the 100-pound person or the 250-pound person if they're both running the same speed? Of course, you'd rather stand in front of the 100-pound person because that's going to hurt less because they weigh less. The bigger something is and the faster it's moving, the more force it has. Would you rather stand in front of a bicycle going 10 miles an hour or a tractor trailer going 150 miles an hour, right? I mean, that's easy to think about once you really think about it. So force equals mass times acceleration. The bigger they are, the harder they fall is the way to remember that one. And an example would be, kicking a ball with a lot of force sends it flying. Kicking with the same force amount of force, but a heavier ball means it won't travel as far. There we go. All right, and the third law is action reaction. For every action, there is an equal and opposite reaction. What does this mean? It means this one is more to do like when you think about hitting a baseball, right? So the baseball's coming at you this way, and then I swing and I hit it, and now it goes the other direction because I had an equal and opposite reaction. It got hit and it went with that same amount of energy. It was coming this way. Now it's going that way. When I jump, so there's a reason why that floors in a gym are made out of wood. Imagine trying to dunk a ball, and think about it when you've tried to do it on asphalt or concrete. How's it work, right? It's a lot better on wood because it's more springy. This is the bouncy ball law. Why does a bouncy ball bounce back up? Now, it doesn't make it all the way back up as much energy as you put into it. Why? Gravity and friction. If there wasn't gravity and friction, when you bounced it, it would bounce right back up, but it doesn't go quite as high as when you dropped it because of gravity and friction. So this is the bouncy ball law. So we've got the, honestly, a bouncy ball dropping and bouncing back up is a good example. Also hitting a baseball or hitting a tennis ball or whatever. All right, I think, no, we're not done. Oh, okay, so that's just a reminder of what Newton's laws are there. So you can check that out. And then that is it. Whew, I thought so. All right, so now you're gonna share. So click the orange share button, and then in the box that pops up, you're gonna put in my email address, harris.kate@nottawayschools.org. So make sure you share that with me when you're done and hit send. And that's it. Have a lovely day. Make good decisions. Bye.